I thought I understood IP fragmentation, and then I tried to implement PathMTU discovery. So what I found out is my coworkers didn't understand either. They were also network engineers. And I discovered a ton of people actually on the internet also had different ideas. So my question here was how to teach people something that they think they already know. I came up with Fragquiz, a game to test your IP fragmentation knowledge. And I'm going to tell you about some of the challenges and solutions in implementing it, and then we're going to play it together. This means you're going to have to like raise your hands or something. And at the end, I'll tell you my packetization layer, PathMTU discovery implementation, which I think has the lowest possible latency PathMTU search algorithm, but maybe I'm wrong. All right, a little about me. I'm Valerie Aurora. I'm a freelance software consultant. I specialize in operating systems, file systems, and networking. I've worked on a bunch of network drivers, TCP/IP, ZFS, ext4, union mounts, and most recently a VPN. All right, so I was implementing blah, blah, blah. So this is PathMTU discovery at a packetization layer, so below something like TCP. So your job is to find the largest packet that can be sent over the network to the host without IP fragmentation fragmentation occurring. So the other programmers told me that our software already never sent fragmented packets and that the don't fragment bit was set on all of our IPv4 packets. That was not true. We were all surprised. And when I looked things up on Stack Overflow and all that, a bunch of other people had very confident opinions about this. So I thought about I would love to tell people, I learned something like this, I think, how can I tell other people? So I thought about replying on Stack Overflow. I'm like, no, they'll just downvote me. I saw that happening to some right answers. I thought about writing a blog post, and I thought, no, people will just tell me that I'm wrong. I thought about writing a program to demonstrate it, and I thought, no, people will just be like, oh, I already knew that. And nobody needs to write this program, and I'm the one who's an idiot. Okay, so this reminded me of something I did many, many years ago, a lot of years, like 20 years ago, the TCP/IP drinking game. So the drinking part is optional. It was a session at early DEF CON conferences. I missed it. I was at the conference. I didn't go to the event. We're talking like 1995. There was no videos. So I just made something up, and it was literally just questions about TCP/IP. I printed them out, played the first game with Alan Cox and a bunch of other people who were in Linux networking. He had some really good questions to add. Yes, the teapot is in there. Everyone thought it was super fun, and we all learned a lot more things about networking. And just want to say the real TCP/IP drinking game I finally found out was just answering questions with the largest number of acronyms possible. Mine's better. Okay. So I decided to write Fragquiz. This makes you guess what will happen. When a particular kind of packet is sent, it records that guess, and then it actually sends the packet and compares it to your guess. At the end, it tells you your score, and then it encourages you to send it to someone else, kind of like Wordle. Here are my implementation goals. I wanted it to have minimal setup, so people would, I mean, this is supposed to just be fun. I don't need you to configure things all day long. I didn't want it to require super user privileges, more on that. I didn't want to write any packet tracing code because I'm really lazy. I didn't want to get fooled by segmentation offload to the NIC or virtualization or loopback. I found so many bugs and things that I was not trying to find. I'm like, I'm not emulating this in any way. I didn't want to require running a separate server program. I hate that. I perf, that's always the thing that bugs me. And I wanted to be able to test IPv6 with only link local addresses, more on that. So the thing that solved most of these things, which I'm sure half of you thought of just now, lower the TTL or the hop limit on the packet and use an unprivileged ICMP listener. So a few operating systems allow you to open an ICMP listener for ICMP packets without super user privileges. Then you can set the don't fragment socket option to what the user requested on the socket that you open. You connect to any open TCP port on any server that's at least one hop away, although it ended up being more than one hop. Same thing for UDP. It doesn't need to be running any particular thing because the packets never get there after the handshake. So you set the TTL or the hop limit to a low value, send the packet, listen for the TTL hop limit exceeded message, and then you parse the IP header to find out what did it send. So this sounds easy in practice, in theory. In practice, I just found a lot of other bugs. In particular, this isn't a bug, it's just a lack of feature that Linux should consider if they want people to develop on their platforms as a macOS first developer, I say. macOS allows all kinds of, a bunch of different kinds of ICMP messages, including time to live exceeded, but Linux only allows echo request or reply. So you have to run it as root. I was like, play this game, run it as root. Well, you can do that on macOS without running it as root, but not for Linux. So yes, there's a kernel patch in mind to make this happen. Many networks just don't generate the TTL or hop limit exceeded correctly or at all. Thank you for I had to go to the RIPE meeting to get a network that did this correctly for both IPv4 and IPv6, but it's only the legacy network. I'll tell you exactly which one here. Okay, so lots of people don't have IPv6 connection at home. I don't have it at home. I didn't check. What was I thinking? I tried to make it work with link local addresses. I wrote a little tiny baby port scanner to be like, is anybody listening? And sometimes somebody is. It doesn't work yet. I think I need to force the hop through the router. So fortunately, we're here. Yes, use the Legacy 87 network if you want to run this. I'm not getting IPv4 TTL from the RIPE meeting one. Yes, and this actually kind of doubles as a check to see what your network does. Anyway, okay, so just a few implementation details. You may have noticed if the router reassembles the packet before it sends the time to live exceeded, you're not going to be able to tell if it was fragmented or not. Who would bother doing that? Well, actually, a lot, including my home access point. So what I do is the program automatically probes until it gets back the fragmented version of the time to live exceeded. So it's gone up to 6 on some of the networks. I think the RIPE one is 3 for both IPv4 and IPv6. My home is only 2. Yeah, so and one of the fun parts about this is that the MTU cache in the OS changes the behavior, the path MTU, sorry, yes. And I'm still working on the code to clear that. For now, I just reboot. That's part of the fun. All right, I guess we're here. I'm so nervous. You know what demos are like, and I've been finding bugs all day long. So including one about 15 minutes ago. In fact, I just kind of left it in there and called it a feature. All right, so we're gonna vote and all that good stuff. Are you ready to play? Woo! Okay. One sec. Okay. All right, we are probing. We're getting 3. Okay. If we send a packet 2,000 bytes long on a TCP4 socket with the do frag socket option, will the don't fragment bit be set? We're going to vote yes over here and then no over here. Put your hands up. Yes, the don't fragment bit will be set on the packet. Okay. And no, the don't fragment bit will not be set on the packet. Okay, we're getting no. Let's see what happens. Will the packet be fragmented? This is kind of a gimme. It's not going to. Okay. It's TCP. What do we do? Oh my God, what's happened? Don't fragment bit is set. So there we go. That's the next one. Okay, so if we send a packet 2,000 bytes long on a TCP4 socket with the do frag, let's see, the default is to run the default socket option, then the do fragment socket option, then the don't fragment socket option. So we will do it again. We will say yes. And this time it's right. Okay, let's see. Now we're doing don't fragment. So This is an interesting thing. What does it even mean for a TCP socket to have the don't fragment option set? Whatever it is, you can only do it once on macOS. Linux actually does define it because it's all about PathMTU discovery, not about fragment or don't fragment. So will the don't fragment bit be set on the packet? Yes? Okay. Okay, and then no. All right, we'll say yes. I honestly don't know. I have no idea. I've been playing this all day. And I'm always like, wait, woohoo. All right, we got one. Let's see, now we're doing UDP6. 2,000 bytes long, UDP6, do fragment. Will it be rejected because it's too big? Yes? No? No, yeah, okay. Will the packet be fragmented? Yes? Yep, no. All right, we have C, and I just want to point out, no matter what's happening, because I'm wrong constantly about this thing, people disagree. Yeah, okay. Really, it's so rare that it actually is right. Well, and of course, half the time, it's a bug in my code. So, you know, it's not the existence of the next header, it's the type of the next header. But that was really hard to figure out because it was reassembling it. Anyway, okay, 2,000 bytes, UDP6, do frag. Will it be rejected because it's too big? Yes? No. Oh, it's the same? Oh, yes, yeah, let's just do it again. Because of the three things. So on Linux, there's more than 2 values. And the default is like weird, and it's not don't fragment or do fragment. So that's part of why if you run this on Linux, you're going to get want PLPMTUD, then you're going to get do frag, then you're going to get don't frag. Guess what? There's a 4th one, probe. Okay. We'll do the same thing again, just to give our score a little juice. Okay. Now we're doing don't fragment. Will it be rejected because it's too big? Yes? No. All right, I think that one's actually right. Oh, for once. I understood that. All right, TCP6. What does do frag even mean? Let's just, anyone care? Will the packet be fragmented? No, I think this one's a gimme, right? This is the one that I was like, oh, this is a bug, because of course. So, okay. Do frag again, same thing. And then what do we have next? We have don't frag. What does it even mean? We'll say no. Haha, okay, we're doing better. All right, final, I think this is, we're getting very, very close. UDP4. This is old school. We've got don't fragment that actually means something. What do you think? 2,000 bytes long, do fragment. Will it be rejected because it's too big? Yes or no? No. Okay, say yes, yes, I agree, it will be no. Will the don't fragment bit be set? Yes. Okay, will the don't fragment bit be set? Yes or no? Okay, we're getting more no's. Okay. Will the packet be fragmented? Yes, yes, no. Okay, great. We're getting there. So this is familiar. More familiar. This is the same thing again. Sorry about running it with the duplication. All right, and now we've got don't fragment. Will it be rejected because it's too big? Yes? Yes. No. Okay. It will. I do know that part. Ta-da! All right, we played the whole game. We got 15 of 19, which is better than I've ever scored. You've got the whole summary here, which is way too long to post on social media or something like this. This is the secret version of it that you can put on your Mastodon post. Yeah, so I think we've got a little more time. I'll just poke it at, show you on Linux one time. Let's see, which I just rebooted because I wanted to clear the path, the path MTU, the cache. The want PMTUD is the default, and it does surprising things constantly. So I recommend running it with UDP4 or TCP4. Let's see what happened here. Let's see. Yes, okay. with want PLPMTUD. So everybody, what does the default setting on Linux mean? It's never talked to this host before. It has no idea. There's no state. What does PathMTU discovery want mean? Okay, so we're sending a packet that's too big for the socket. We have want PLPMTUD set. Will it be rejected because it's too big? Yes? No. I think it's slightly more no. Will the don't fragment bit be set? Yes? No. Okay, we've got yes. Okay, that's a combination. Let's see, the packet was not too big and the don't fragment bit was not set. Let's see if that keeps happening. Let's say no again, and then we'll say no again. Will the packet be fragmented? Yes. All right, go. Yep. So what I always end up like running these a few times with the answers from the last time, and then being like, oh no, it's not the same. All right, now let's do TCP4. At this point, does it know about PathMTU or not? I don't know. Will the don't fragment be set if we're sending a packet with the PathMTU discovery want? Yeah, yes or no. Yeah, now we're getting to the like, what? I don't even know, but we've got one hand for yes, so let's go for it. Yes. I don't know, and then let me see if UDP does the same thing. We said no. What did we say before? What did it do before? Before it had no don't fragment bit, and yes. It's different now. Welcome to the PathMTU cache. Okay, I think we've got 3 minutes left, so I'm going to tell you about my my packetization layer search algorithm. All right, so credit where credit is due. I co-implemented this on a packetization layer similar to WireGuard. Sorry, can't say which one, with Salman Algemez and James Tucker. RC8899 says implementations could optimize the search procedure by selecting step sizes from a table of common PathMTU sizes. I use some research published at RIPE meetings actually to be like, well, these are the PathMTUs that are out there. Importantly, different than MSS. So we just sent all packets of all of the sizes all at the same time. And the biggest one that came back is the PathMTU. So to keep it up to date, every 10 minutes you have a timer. You send a PathMTU, your current PathMTU plus 1 byte-sized packet, just to see if the MTU increased. If it did, you send them all again. It's got 1 round trip latency. There's only the timer that you have to have to re-explore the PathMTU. It worked. Surely somebody has implemented this before. I couldn't find anything written down anywhere on the internet. So if you know someone who implemented that, please let me know. I would love for this to be part of things.